Thank you so much. Thanks for joining in. In today's session, we are going to learn more about transactions. In our previous session, we've understood the introduction of transactions, inputs and outputs. Now today, understand the portion will be like a revision also. Okay. So I request you to mute if there's any background noise. Okay. Yes. This is great. So I'm going to share my screen here. Okay, give me a second. Yes. I hope my screen is visible now. Yeah. So today we are going to continue from where we left yesterday's session. I mean, the previous session, we have understood more about the stack operations. We understood about the structure of input and output. So we're going to run through that also once again towards the second portion. So let me first point out in the direction of what module we are covering. We are going to start module 5 today, the revision of that. So the people who have joined recently, I'd request you to go through the previous lectures also. The format of these hackathons are going to be in this way. So the primary faculty here, Professor Pandurangan, will be covering the lectures and we would be revising them in a cyclic fashion, right? So first we will be revising from the beginning till end, and then we keep on doing that particular revisions, right? So if you have to identify the lecture that we are covering on Teachable, so this is where we find it. Okay. So if my screen is visible, now you would go to your Teachable. On your Teachable, you can see that this will be the section that we are covering, right? So let me show it to you. So the module 5, where we are talking about transaction and testnet practice, this is what we are going to revise today, right? So if at all you have finished the previous modules, I'd request you to go ahead and take the quiz. The quiz is very well formatted. This will also help you in your end sem exam as well, right? Okay. So thanks everyone. Great. So let me go ahead and begin with this session. So if you remember in our previous session, we have gone through an example. So let's go ahead and work with the same example, right? So any block we can take from the blockchain. I'm going to take the block 5000. So that way, how do we do that? So people who are joining for the first time, you can see that we go to the blockchain.com, we go to Explorer, and within the Explorer, okay. If my screen is visible, okay, let me stop my screen share and share again. Is my screen visible now? Yes, okay, great. So I was telling the session will be in the module 5. So this is what we are revising today, right? So now if you look at the previous session, what we have done is we went to the blockchain.com, we went to the Explorer and searched block. So we are going to check the block 5 lakh, and on Bitcoin block 5 lakh, we have seen the transactions in that input and outputs, right? So if you remember, we have gone into one transaction. So there's a lot of transactions if you see in our previous lectures, we have understood what type of inputs there are. So you can see that there are 2,700 transactions, out of which we are just going through one particular transaction. So this is one block. One block is 1 MB of size, and in that there are 2,700 transactions. So in this, we have gone through, like, if we take this one particular transaction, there are two inputs and two outputs that is also specified here. And you can see that if you go ahead and click this particular transaction scripts, you can see that this has a particular format, right? So you can see that here there is a PK script or script PK, the public key script, and there is also a signature script. This is what we have discussed in our previous session. We have went in detail about how the operations are also performed, right? In the two also, there is a similar format of PK script, right? So we've also understood what is this, like this is going to be the public key hash, right? So we are going to cover that once again a little in detail, right? So each transaction has multiple outputs, right? Like in this particular transaction, we had two outputs. Out of that, what is there in each output specified, right? So whenever there is an output that is going, the amount to be transferred is specified in satoshis. We've also seen that example of Tom trying to send to Alice, right? So in that also, amount will be specified in satoshis, right? So you can see here we have more information also. So which, like if you see fees here, you can see SAT is satoshis. So now the fee here is 17,463 satoshis, and we also understood how many satoshis make one particular Bitcoin, right? So all of the transaction here, either you mention in 0 point and the points in decimal a fraction of Bitcoin, or you can mention it in satoshis, right? So the amount to be transferred is specified in satoshis, and there is something called the locking script, or it is also known as multiple names. Professor in his lecture also gives us all the other names also, right? So either it is called a locking script, or a public key script, a witness script, or a cryptographic puzzle, right? So this is what it is called, right? So now you can see that this particular transaction, whenever you have an output, it has all these properties in that, right? So whatever amount has to be sent is mentioned, and all the details are mentioned, right? So what all other things an output will have, the output will have the transferred amount to be transferred and the script PK, right? So which is also known as the witness script, or else the cryptographic puzzle, right? So professor also explains why it is called a cryptographic puzzle, because it is only, the ownership will only be unlocked by the person who has the secret, right? So it is not possible for anybody else to be able to claim the ownership, right? So we also understood the language the language that will be used by the blockchain network is called script. In our previous session, we understood about script. A few references were also shared where we understood how the commands of the script language are also performed, right? So we'll look at that. There's also a stack-based implementation as well, right? So we'll also cover that today in detail. So this stack performs each operation, and all of the data that is there in these locking scripts, and all the public key script or the transaction amount, all of this data is stacked or pushed into the stack, or popped out of the stack, right? So this is called last in first out, or the pop operation, right? Am I audible? If Revati ma'am says I'm not audible, so ma'am, you might have to join audio if that is the case. Is my audible? Is my voice clear? Am I audible? Yes. Okay. So these are what are there in outputs. Thank you so much, ma'am. Thank you, Ravina sir. So our transaction can have multiple outputs and all of these are indexed, right? So if you go to our example, which is here, share my screen again. Now every transaction has an index, right? So we'll also understand that. So if at all you want to watch it in detail and see this in detail, you can click on this JSON, which will have more details, right? So overview will be this. If you click on JSON, you can see that there are two inputs. There is one set of input and there is another set of input, right? So these inputs have a transaction ID and the sequence also, right? So there will be a sequence number and there will be a signature script, right? So there are other values like the PK script is also there, right? The value, the address, all of these are there in inputs. Similarly, in output also there is address, the amount, the transaction ID, the value, and all of these details are there. So this is how we have seen what all is there in a transaction, right? So let me bring up the reference that I've shared last time, which will give you an understanding more about the language script. Yes. Yeah. Share my screen. Yes. Hope my screen is visible. Yeah, now it is visible. Now, script is a language that is used by Bitcoin, and it is a very simple language. It only performs a specific set of operations. You will not be able to solve any typical engineering problems. It is only there to process, verify all the transactions that happen on the blockchain, right? So out of these, we have seen we only use a few of them, like the OP/DUP. So what happens? OP stands for operation. DUP is nothing but duplicates the top stack item. So if there is X as an input, it will duplicate and give us that output. And similarly, we have other operations like equal verify, right? It is going to verify if two two parameters are equal, and then it is going to verify it, right? So if they're visible or not, right? So all of these details we have understood, right? So now as we proceed forward, we have also seen an example here. This was the example where we have understood what a stack consists of, right? So if you see this image, it becomes easier, right? So let me also, instead of moving GIF, I'll share my screen and I'll walk you through these steps. Great. I hope my screen is visible now. Yes. So now if you're able to see my screen, so what happens in this stack is, first, the stack is empty. And if you remember, we have the script signature that is coming from the input. And there is also the PK script, the public key script, that is also coming here. So you can see that the operation DUP, the operation #160 equal verify and check signature are there along with the public key hash, right? So whenever an output is being sent, like if A is sending to B, B's public key hash is also included in that, right? So this is the first step. So what we are going to do here is, first go to the next operation. Okay. I hope my screen is visible again. Let me bring it back. Okay. For some reason, I'll be sharing my whole screen, and maybe from there it will be easier. Great. Okay. So if we look at this particular screen, you can see that this particular screenshot of that GIF, first the stack is empty, then the signature and the public key, both of them are stacked, and then the first operation, DUP, is performed. So when DUP is performed, the public key is duplicated, and then the next operation, which is hash 160, is performed. What hash 160 does, it is going to first do the SHA-256 hashing, and then it will do the RIP-EMD 160 hash. So it is double hashed, and that value is retained in the stack. So the next operation, then the public key hash, which is sent like OPDUP hash 160 public key hash, then this is also put up into the stack, right? So once both of them are added, then equal verify, the next operation, it is going to verify if both of them are same, right? And once that is done, the final operation, checks signature, is going to check if the signature and the public key are matching, right? So now this checksig uses the elliptic curve digital signature algorithm, and is going to check if this particular public key and this signature are corresponding to each other, right? So, and then the verification is complete. So this is how the stack operation, stack performs all the operations. And this is how the script language, like all these commands and all this data, is handled by script, right? Script is the language that Bitcoin uses, right? So if this particular portion is clear, right, how the stack is used and how script language is using all these operations to stack and perform each operation one by one. So if this is clear, type C in the chat box. This is something we have covered in detail in our previous session. Thank you so much, Sujuma. Great. Thank you, Sharayu. Thank you, Ravindra sir. Right. So let's come back to our slides now. Now we have seen all of these in our previous session. So these references are also shared, so you can learn more about script. So this is what outputs are consisting of. This is what is comprised in an output. So let us have a look at the inputs also. All right. So now inputs will have transaction ID, and there is a version output, which is nothing but the output sequence, because whenever any output or input is put up in a transaction, it is going to have a sequence, because there could be multiple outputs in a transaction, and our node is going to only check, okay, this is the transaction ID, and out of that, if the index of that output or input is 5, it is only going to check 5th input or output, right? So that particular value is also there, and there is an unlocking script, right? So this unlocking script is the SIG script that we have checked in our stack now. So what happens is the public key hash that is specified in the output and the script key, the script signature, because this have to correspond with each other, right? So whenever a verification is done, so we'll understand that. So this script signature is generated by A when a transaction is being sent. So then if C is a person who is sending some Bitcoin to A, then he'll only be able to prove his ownership because that script signature is generated by the secret key that A has, right? So this is done by the elliptic curve digital signature algorithm, which we have discussed in our previous hackathons, right? So this is what an input consists of. So everyone can see this transaction, but signature can be generated only by A using the corresponding secret key. So which is something that we have understood when we are doing the ECDSA, right? So let's try to understand what all points that Professor Pandurangan sir walks us through, right? So in transaction verification also, let me bring up the screenshot that Professor Pandurangan has shown. So now what happens is, whenever a node is trying to verify a transaction, it uses the signature and the public key script from the input of the previous transaction, right? So we'll see that with the diagram, it becomes easier. So verification is done by all nodes, right? So for example, whenever a new transaction is put up on a block, it is going to be verified by all the nodes. Why? Because if at all a transaction, somebody, in their interest says, he verifies a transaction and says that this transaction is verified, it has to match with all the other nodes, right? So whole of the blockchain works on the system that most 51% of the nodes are going to be honest and are going to do the verification thoroughly, right? So if everybody lies that this has been verified, then it becomes, you'll not be able to verify properly, right? So that is the reason verification has to be done by all nodes. So when that verification is done, the public ledger is updated in all places, right? So verification is done by all the nodes. So the stack operations are performed, and we have seen how the stack operations are performed in detail, right? So now, if at all, if we want to see this in writing, similarly, whenever we are going through an output, it will have the same structure, the OPD, the OP hash 160, 20 byte public key hash, okay? The 20 byte public key hash, or it is also 20 byte public key hash. Each byte has 8 bits, which will also be represented, which can also be represented in 40 hexadigits, right? So that is what is there. And then there is the operation equal verify and operation check signature, right? And that output will also consist of the locking script or the witness script or the cryptographic puzzle, right? So the PK script, right? It's also known as the PK script. And now this is where we'll try to understand. So for example, if A has 1 Bitcoin and this 1 Bitcoin is being sent to multiple people, right? So one person is receiving 0.1, 0.25, 0.1. So there are 4 people who are receiving in this particular format, 0.1, 0.25, 0.1, 0.05. Now, out of this 1 Bitcoin, A is sending it to 4 people, and there will be an unspent transaction output where the user A has to specify that 0.495 has to be sent back, because this all in total coming to 5, right? So 3, 4, 5. So now, 0.5 is being sent to these 4 people and send the 0.495 back to me. So when you specify that, you are indirectly also specifying that the transaction fee that you are willing to give for verifying this particular transaction with these 4 outputs is 0.05. Right? So as we have seen, transaction fee is nothing but inputs minus outputs. So the value, input value minus output value, right? So if this example is clear and with what all an output consists of, type C in the chat box, right? So how is transaction fee calculated, and how you specify how much transaction fee has to be collected by the miner? Thank you, Sujama. Great. So now this is what is comes a structure of the output. And similarly here, okay, this is the same thing. Now, what happens during verification, right? So during verification, what is happening here is first the signature and the public key script that you have seen also in the stack screenshot that I've shown. It is coming from the input of the transaction happening from A to B, right? So whenever the input is going to have the signature and the public key, and after that, the other set of operations from the output are going to be obtained, right? So first OPDUP, OP hash 160, OP equal verify, OP check signature. These are all commonly taken out, obtained because that's a generic structure. But the public key hash, which is the 40 hexa digits, that is obtained in this particular fashion, right? So what happens is any node that is trying to verify, it has got the signature and the public key from the input. Now it is going into the transaction ID. It is going to verify which transaction this was, right? So it's going to check the input that came from TCA, right? So which is basically referred, the node goes to the transaction referred in the input TCA, right? So C is trying to send something. So A has 1 Bitcoin, which was sent by C, right? So it will see, okay, now does A has genuinely this 1 Bitcoin? Let's try to see where it came from. So then it goes to C and A's transaction and sees, okay, right? So there was this transaction ID and there was this input number. The index of the input is this. Yes, and this is a genuine transaction. A really has 1 Bitcoin. Now what it does, then the node goes to the output. And in that output, it will, from the locking script, obtain the whole of these operations along with the public key hash, right? So because now we have understood the structure of input, now we understood the structure of output. During the verification, the third step is understanding transaction verification. During the verification, this is how it is tagged. The signature public key comes from the input, and from the output, basically the locking script is obtained. So this is how the transaction is then verified. So now professor also goes and explains the stack operations that we have done, right? So if there is any query till now, because this is more of a revision of what we have done previously, if there's any query till now, you can go ahead and put it on chat or ask. If everything is clear, we can go, you can type C in the chat box. Thanks. So people who are watching us on our social channels, you can use the comment section. Thank you, Sushma ma'am. Right. So if you go through the module 5, the first 1.5 hour of that particular session is something which we have discussed, right? Thank you, Sharaya. So now, because we've understood this portion of it, we are going to go a little bit back and also revise a few of our previous concepts. Yes. Let me share my screen. Yeah. So previously, if we go a step back and try to understand how we came in here. So this is what we have covered till now, right? So we have understood the elliptic cryptography for digital signatures in our previous sessions. All the messages are encrypted as points on the elliptic curve. Now, because we are discussing the how this script language is, how the script is using stack to perform these operations, and how checksig is using the elliptic curve digital signature, the whole of the algorithm. So this is all inbuilt within that. So you're not going to manually go ahead and do verify. All of this is being done by the script language itself. So every public key is going to have a corresponding secret which will be generated based upon the elliptic curves equation. So the elliptic curves equation was y square equal to x cube, so x plus bx plus c mod p, right? So we have seen that, and we've also understand the use of private and public keys. So whenever what this algorithm does, it takes a message or an agreement, it is going to hash it and produces a signature that is derivable only by user. Meaning here, if A has got an input, he is only the authorized person to prove the ownership or prove that particular signature, right? So this is what we have understood previously, right? So the same thing, details of ECDSA. This is going to be a 256-bit signature, and every signature has these two components, S and R. And this also has a solid mathematical proof behind it. So it is difficult to forge. And all of this we have discussed previously, right? So the signature and the verification algorithm ensures the authenticity of the transaction. If there is data corruption, for example, if somebody is going to say, I have also sent the same 1 Bitcoin to other person, it will easily check if that particular person is the right owner for this. Will the secret key of that person prove the ownership of the funds? If it is a manipulated transaction, the hash will not match and the transaction will be rejected. So here Professor Pandurangan sir also explains, for example, if there's a miner who has let's say 5 lakh block only. In that, there were 2,701 transactions that were verified and uploaded onto that block. Let's just say if there is even one corrupted transaction where by mistake or in self-interest, a person goes ahead and says, I have verified this transaction without verifying, or says a counterfeit transaction as verified, the whole of the transactions, all of the 2,700 transactions will be blocked. So what happens is that blockchain will be rejected, that block will be rejected from the blockchain, and all of the effort that was gone, all the effort that went into verifying all the other transactions also go in vain. So that is the reason each miner triple checks all the transactions before uploading onto the block, right? Triple checks as in verifies all the transactions, and 100% whenever he's 100% sure, goes ahead and uploads them onto the block. There is no scope for data corruption and transmission error, right? So the verification algorithm checks certain conditions mathematically and only accepts a transaction if it is generated properly and the appropriate parameters are passed, right? So we have also understood how a wallet address is generated, where we have understood the double hashing here for the first time, right? Now we have seen that the script has an operation which is called hash 160, which first takes the public key of that person, goes ahead and first hashes with SHA-256, and then hashes the output of that into by using the RIP EMD 160. So whatever output is there, this 160 bytes or the 160 bits or 20 bytes, this is again converted into a 58 base system, right? So we'll also understand that which is more of a wallet address, right? So the public key of the receiver is identified by the hash of the public key. The public key hash is made available to the world and is used to uniquely identify the recipient of the transaction. So now, because we have seen the transactions, now this should make more sense how this is being used, right? So the hash of the public key is used to encrypt the public key for additional protection, right? So the hashing of the public key makes the information more compact, right? So all of this we have discussed, and whenever a wallet address is created, there is also something called a checksum that gets generated. So whatever this is there, this is the hash 160, where the public key is double hashed, but sometimes during transmission or whenever a physically the ID is being shared, or there is a typo in the hash also, there is always a checksum that is accompanied with that, right? So we have seen that with an example here. Go ahead and show that. Here is my screen. So whenever the data is there, the 20 bytes data, there is also an accompanying checksum, so that we know that the data is not corrupted. For example, if this is the which is double hashed, for example, the public key was first hashed using SHA-6, and then it was hashed once again using the RIPEMD. The output is this 20 byte bit stream. Now there is a corresponding checksum that gets generated. For example, if it's a different data, if the hash is different, I'm going to change it. You can see that it will not be okay. So the checksum will change. So corresponding to each data, the checksum is generated. So whole of this, while a wallet address is being generated, whole of this, the data plus checksum is used for converting it into a base 58. Okay. So I request members to mute. You have joined now. Yeah, great. So now what happens is this provides additional security, because now the checksum here is now D0F3 and all these characters. If, for example, whenever the data is being transmitted or sent to someone, if there is some manipulation or some change happening, let's say I'm going to say here, instead of A, I'm going to say 5. What is going to happen is the checksum mismatch is immediately traced, and you'll know that there is some manipulation that happened in the data, or there is some error in the data. So you will know that this wallet address is something that is non-existent or something. So we have to be anyway double careful whenever we are entering the wallet address, but also there is some additional care that is taken while the wallet address is being generated, right? So this is not the final wallet address. The data plus checksum is the penultimate step in generating the wallet address. The final step is converting it into a base 58, right? So I'm going to show you that also. So now whatever input that comes here, so I'm going to take this example. So whatever input that came here goes into a base 58, right? So whatever the hexadecimal output that came, when you enter that and convert into base 58, the wallet address is then generated, right? So this is going to be the wallet address. And if you understand the base 58 system, it will have 58 characters because now decimal has 0 to 10 characters. Similarly, hexadecimal has 0 to 15, 16 characters. Similarly, base 58 will also have 58 characters, right? So what are the characters here is, now you can see that a few ambiguous characters are removed out of this. If you see, 0 is not part of this particular base 58, because what happens is if 0 is there, people, when you're manually, in the initial days, when you're manually writing and sending it to someone or storing it, you might get confused if is it a capital O or a 0, right? or if is it a small o or a capital O. So this becomes a little confused. So for that reason, this one character is removed, and then the capital I. You can see that there is a space here. Capital I and L, the small case L, both look same. Like this is I and this is L, this is small l. So both are going to look same. For that reason, that particular character is also not used in base 58, which means whenever you get a wallet address, you will not have 0 and capital I and the other operators, like other characters also. The capital O is also excluded. Similarly, the small l is also excluded. So whenever you send, the chance for confusion is very less, right? So this is how we have generated our wallet address, and that wallet address also consists the public key hash. So for that reason, whenever a public key hash is sent to in the inputs or outputs, you know that it is a properly hashed and encoded system, right? So that is what encoded value, right? So this helps us. The use of a checksum ensures error-free transmission. The concept of a checksum in the context of cryptocurrency transaction also is being discussed, right? So the practice of checking the integrity of digital transmissions through coding and encoding, we have discussed that. Use of the checksum to ensure error-free transmission, and the concept of a checksum also we have something discussed, right? So these are the thing. Similarly, the base 58 also we have discussed, and the characters that are excluded, the uppercase O, the lowercase l, uppercase I, and these small o, the lowercase o, also are excluded. So now if we just revise, so today's session is relatively smaller than our previous sessions, because the module 5, half of that particular things that we have discussed is more of a revision from our previous session. So that is why we're also revising our previous concepts and making sense of what we have learned very recently, right? So now if you go back a few slides and come to the same example of Tom and Alice, it becomes more clear, right? So when Tom was trying to send 5 Bitcoin, he had 5 Bitcoin and he was trying to send 2 Bitcoin to Alice, there were 2 outputs that got generated. Now, because we have better knowledge right now, what also happens here is when Tom is sending 3 Bitcoin back to himself, this unspent transaction outputs are being created. Whenever he's sending this 2 unspent transaction outputs that got created, he can also mention that only send 2.95 back to me, and the 0.05 is going to be the transaction fees, right? So after this, we have understood the real life example of the block 5 lakh and seen how inputs and outputs are stacked, right? So we understood about the unspent transaction outputs also, right? So how this happens in real time is when now Tom has received, let's just say he has received from another person, Carol, and other 3 people, he has received 2 Bitcoin, 1 Bitcoin, 1.5 Bitcoin, 0.5 Bitcoin. So all in all, he has 5 Bitcoin in his wallet. And whenever what we meant when he unlocks the input here is, and the index of that input, for example, he wants to transfer 2 Bitcoin. So he has a specific input that is 2 Bitcoin in value. So the index, the 1 with 2 Bitcoin is unlocked. And then while sending to Alice, that particular output is locked. 2 Bitcoin as an output is locked and then sent to Alice. Just in case if he wanted to send 2.6, so he does not have a 2.6 Bitcoins input directly available. So 2 inputs that he got, which is 2 and 1 Bitcoin, both of these, the index 1 and 2, 0 and 1. So index starts from 0, the index 0 and 1. So these, both of them are first unlocked from all of his inputs, and then while locking, these two are locked, and only the output value that is sent is 2.6, right? So this is what happens in a visual format, right? So we have also understood from here only how the transaction is specified in Satoshis, and how UTXOs get destroyed disqualified from the UTXO database when a transaction becomes spent, right? So you also understood all of these examples as well, right? So then we have also understood what is the mindset of a miner and how he gets a block incentives also. So whenever a miner is verifying, he's verifying it for the incentive of the transaction fee, and transaction fee is inputs minus outputs, right? So you can go to the block, any particular block, and you can see that the total input value and the total output value. So if we are going to do the abstraction, should be our transaction fees. So let me just go ahead and do that. So now the transaction fees should be 0.000174663, and that is what here it is, 17,463 satoshis, right? So this is what the fees is always, it's input minus output, right? So these all conceptual things that we have learned have now been strongly standardized and understood by all of us, right? So if now all of this system, from where the transaction is happening, the UTXOs, and how the locking and unlocking is happening, how the structure of inputs and outputs are there, and how script of Bitcoin is using stack to perform these operations and validate a transaction. So all of this is, I hope all of this is more clearer now. If we are clear with all these concepts, we can conclude today's session. So people who are clear can type C in the chat box. If there's any query, we can go ahead and take it up. Yes, thank you so much, Ashish. Thank you, Sujima. So I would request everyone to go ahead and complete the quiz and lab portions. So basically, the labs that are happening in the course are in a way a practical revision of the previous sessions. So I'm not again going into revising the labs. So I request you to go ahead and also go through the labs and go complete the quizzes also, right? So now in our next session, we are going to understand more about this transactions and verification, and then we'll move on for our further modules, right? So then we'll also get into a little of solidity and understanding how we can use simple code to create a few smart contracts also, like towards the end. We're also going to do that. Yes. So thank you so much. And I want to, understand, if somebody wants to give any feedback, especially with the module 4 and 5, how you think this particular concept is helping us verify transaction, understand any particular takeaways that you want to give, you can unmute and share your results, right? So where you can see what this knowledge is going to help you with, right? I request anyone to go ahead and unmute and share their results. You can put it on chat or just unmute also if you are not comfortable on coming on camera. Yes, Prashant says, yes, ma'am. Thank you so much. You're on mute. You're on mute.
Yeah, I think the transactions are and the concepts behind it seem to be the most fundamental part of the entire blockchain technology, and it is we had already, of course, I had already gone through Professor Pandurangan's lessons, and Sachi's your explanations. It further clarified and made it stronger, the concepts. Overall, great. It is, I'm thankful.
Thank you. Thank you so much, ma'am.
Just I want to check when we are going towards this solidity.
We'll go that. Yeah, so it will happen towards our end of our module 10, madam. So towards our module 10,
Okay.
we'll be going into that.
So you
also.
will you be covering, you or somebody else, will they be covering the first principle, I mean, in terms of programming, the first
Yes, we'll
principles
cover from
also?
fundamentals. Yes,
Like
yes.
Python, whatever.
Correct. Similar, very similarly. So because you also attended the Python sessions being part of Gold. Similarly, we are going to cover from fundamentals, madam.
Okay,
right? So
that is great. Otherwise, we should start now itself ourselves.
No. We'll cover from all the big, all the basics, and while we are learning those also, if there is any
how it can be installed and so on.
Exactly. So most of it would be online only. Like for Python, how we use Colab, we'll be able to work with that and do a little of smart contracts and all. So we'll cover the basics of it, and once we're confident enough, we can go for complex ones also.
Okay, thank you. Thank you.
Thank you so much. Yes. So anybody else who wants to share their results, especially specific to previous models, even if you want to share any key takeaways, that was something that was new to you or unique, you can go ahead and share about it. Yes. We have Vijay from our social channels says, okay, so Rahul sir, so basically if you have recently joined, I'd request, because I could not see you in the beginning. So these revision hackathons are going to be a revision of what professor has covered in the live lecture, right? So if you go ahead and go through your Teachable, you can start from the orientation, start from these lectures, and understand more about it. And in these revision hackathons, we are going to revise the same concepts, right? So we also have that the recordings of the same in the inner circle as well, right? And if you have any specific query also, sir, if there's anything that you are facing a challenge with, so then you can always reach out, right? So I will be able to guide you onto the right direction. Great, thank you so much, sir. So even if you have a query that comes in other, like now we have covered till half of module 5. If you are in module 2, if you have a query in the doubts clarification session that we have towards end, you can bring that question, right? So me or other members who have completed all of that will be able to answer, right? So I would encourage you to go ahead and start by self, and maybe you can catch up to while we are covering the other modules in the revision hackathon. If not, also the revision hackathons will be happening in a cyclic manner, even by our other facilitators also. So you can attend any of that and strengthen your concepts. Yes. So Sharayu says, yes, thank you so much. Thank you, Suju ma'am. This concept is new to me, but the points which you explained from module 4, that all are clear to me. Yes, thank you so much, Sharayu. Great. Okay, then. So this was a really smaller session. Thanks for all of your time. And we are going to cover more of module 5 as we go forward. If whatever the sessions that are happening between 16, 17, 18, and 19, there is a specific event that is happening where the team of Pixeltest will be there. So all of those sessions will be covering, like, the dates of that you will receive over email. So I'm just, because people who are there here in session, these whatever hackathons that are happening in these particular time frame will be covered once we are back on 20. with the same schedule. All of these details will be sent over email.
Sachi, can you repeat what did you say? 16?
Yeah.
17?
Yeah. So basically, these particular whatever hackathons that are happening, scheduled for Python and blockchain that are going to happen 16, 17, 18th. These dates will be doing those sessions after 20th, madam. So that is what is being mentioned. You'll also get this update on email, right?
Okay.
The next section update will be there. So it will not, because we are habituated in the Python happening in these 3 days and blockchain happening these 2 days. So maybe for these 3 to 4 days, I will do it post 20th.
Okay.
Yes.
Good.
Yes. Thank you so much. It will be a break also.
Yeah.
Yes, ma'am.
I do have
Correct.
a function to attend.
Yes, yes. Especially for people who are in gold, who are attending both of them back to back.
Yeah, correct.
Yes. Thank you so much, everyone.
Thank
All of
you.
the updates will be shared over. Thanks, everyone.